Hello, Math 7 students. We are beginning Module 2, Lesson 6's lesson, and Module 2, Lesson 6's lesson is Understanding Subtraction of Integers and Other Rational Numbers, and it can be found on page 62 in my comp book. And here is page 62 in my comp book. Understanding subtraction of integers and other rational numbers. So for the last couple of lessons, we have been working really hard with understanding adding of integers and other rational numbers. And today we're switching gears and we're going to talk about subtraction of integers and other rational numbers. The goal, today we will learn the rule for subtracting integers and other rational numbers. The question that I want you to think about is, what is the same as subtracting a number? What is the same as subtracting a number? So basically, I want to open it up with asking you a question. Looking at these two math sentences, expressions, they don't have an equal sign, so they're called expressions. They're also known as math sentences. One of them says 8 minus 12, and the other one says 8 plus a negative 12. My question that I'm asking you is, are these two expressions right here the same? Okay, and there's one way to test it. The way to test it is to use our models that we've been using to figure out that they are the same or not. So just because I'm trying to help you remember all of the different models, I'm going to use the number line model for this one, okay, and then I'm going to use the chip model for this one to prove if they're the same or not. So if we have 8, we start on 0. So we're going to say this is 0 right here, and it says to go positive 8. So I go 1, 2, 3, 4, 5, 6, 7, 8. Put my tail on 0, go to 8, like it says, and then it says I'm going to subtract positive 12. Subtract positive 12. So if I'm subtracting, I'm taking them away. So I'm going to start right here, and I'm going to take away 12 of what I have. But the problem is I only have 8. So if I figure that out, I've got to take 12 away. So let's try. I'm going to take away 1, 2, 3, 4, 5, 6, 7, 8. But all I have is 8. So if I keep going, that means that I have to keep going down the number line. So that would be 9, 10, 11, 12. And when I stop, what number do I have to land on? Negative 1, negative 2, negative 3, negative 4. So I get a negative 4. Okay? So that's an interesting picture. I had 8, and I took away, or I subtracted 12, but I only had 8 to take away. So now I owe, or I'm in the negative, 4 more. So it's negative 4. Okay, so now let's try this one. It says that I have 8 positives. 1, 2, 3, 4, 5, 6, 7, 8. This is what I have. I have 8 positives. Now it tells me to add 12 negatives. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are all negatives. Okay, and then I make my 0 pairs. 1, 0, 0, 0, 0, 0, 0, 0. And what am I left with? A negative 4. Okay, so go back to the original question. Is this expression the same as this expression? Well, this equaled negative 4, and this equaled negative 4. So yes, they must be the same. Okay, now the reason that we're asking you that is because we need to know that adding and subtracting can be the same thing if we remember the rule for adding the opposite. So I want you to look at something. If I have 8 and I'm subtracting 12, what would happen if instead of subtracting, I made the operation adding? But when you're adding the inverse, the opposite of that number. So the 8 stays the same. So I have 8, but instead of subtracting, I'm going to add the opposite. What is the opposite of 12? The opposite of 12 is negative 12. Okay, So you can take this simple expression right here and change it from a subtraction problem to an adding problem by remembering that subtraction is the same as adding the opposite number. Okay, the opposite of the number. Okay, so look at it again with me, please. 8 minus 12 equals exactly the same thing as adding, so change the subtraction sign to adding. So we're not taking anything away, we're actually adding the opposite of the number. What is the opposite of 12? Negative 12. Okay, so let's try another one. How would we do this? Let's say that we have 15 minus 25. Okay, again, say it out loud with me. Subtraction is the same as adding the opposite of the number. What's the opposite of 25? Negative 25. And bring down your 15. So you have 15 minus 25 is the same as 15 plus a negative 25. And the reason why we want to do that is because if we're using the chip model, this makes sense. I start out with 15 chips, then I'm supposed to take away 25 of them. Well, I don't have 25 chips to take away. Okay, I don't have 25 chips to take away. So what I can do instead of taking away 25 of them is I can add 25 negatives. Okay, I can add 25 negatives and then I get the right answer. All right, let's try one the other way. What if the problem said 7 minus 5? Okay, we're going to prove this. So we are saying that subtraction is the same as adding the opposite of the number. What is the opposite of 5? It's a negative 5. Okay, we're going to prove it with the chips. Are you ready? So how many chips do I have? I have 7. 1, 2, 3, 4, 5, 6, 7. I have 7 positives. And I'm supposed to, help me, take away 5 positives. Look at it. That's a positive 5, right? And this symbol says take away or minus or subtract. 7 subtract 5. 7 positives subtract 5 positives. So I'm going to circle 5 of them, and I'm going to take them away. That's what that arrow says. They're gone. So when they're gone, what do I have left? I have 2 positives left. Okay, let's model this one with chips. So I have 7 positives. Okay, and then this time it says that I'm supposed to add 5 negatives. Okay, 1, 2, 3, 4, 5. They're negatives. And then what do I circle? My 0 pairs. And what am I left with? 2 positives, just like I'm left with 2 positives up here. So we proved it again that when you subtract any two numbers, you can add the opposite and you will get the exact same answer. Okay? So the reason why I'm teaching you this, boys and girls, is because you're going to get into problems that are really difficult. But if you remember, every time you see a subtraction symbol, if you remember that you can turn it into an addition problem of the opposite, then it will make your life so much easier. Okay, so let's take a look at this really quickly. Subtracting integers and rational numbers is the same as adding the opposite, which we just talked about. So if we have negative 4.5 minus a negative 8, then what we have to do is we take this subtraction operation and we change it to add. So we have negative 4.5. The minus becomes a plus, negative 4.5. The minus becomes a plus. And then we take the negative 8. The opposite of negative 8 is 8. So negative 8 becomes a positive 8. All right? So remember, a subtraction problem is exactly the same as adding the opposite. Subtraction means the same as adding the opposite. Subtraction means the same thing as adding the opposite, and that's what this shows us right here. All right, and then I did the number line to prove it. So it says that we have negative 4.5. So you go on your number line, go to the left to 4.5, and then it says that we are going to add 8. or subtract a negative 8. But we already learned that subtraction is the same as adding the opposite. What is the opposite of negative 8? It's 8. So we're going to add 8, and we get 3.5 as the answer. Okay? So boys and girls, this lesson is really fun. What I want you to take away from, though, is that if you have a subtraction problem and you don't want to do subtraction, then you need to remember that subtraction is the same as addition of the opposite. Subtraction is the same as adding the opposite of the number. Subtraction is the same as adding the opposite of the number. So we learned a new rule, and the rule for today is, today we will learn the rule for subtracting integers and rational numbers, and that rule is, everybody say it with me, subtracting is the same as adding the opposite. What is the same as subtracting a number? Adding the opposite, okay? And we'll play with some more of those in class on the board. All right, that's it, my dears. Have a good one. Bye.